Belgium Sunwall from ABN12. Tycho Brahe and Johannes Kepler. Tycho Brahe is a Danish astronomer who conducted precise observations of the positions of the planet during his time. He invented different astronomical instruments with the help of his assistant. He made an extensive study of the solar system. He was also able to determine the position of 777 fixed stars accurately. From 16,000 to his death in 16,001, he was assisted by Johannes Kepler. Johannes Kepler is a German mathematician and an astronomer. He worked on his vast collection of data and derived mathematical relationships. Kepler became a Brahe's successor after his death in 16,001. He was given a vast collection of observation of Mars. He also continued Brahe's unfinished work. Kepler proposed the three laws of planetary motion during the early 16,000. He was able to synthesize the huge amount of collected data of Tycho Brahe. The three laws describe planetary motion in a heliocentric model perspective. His first law is Law of Ellipse. Law of ellipses. It describes that planets move around the Sun by following an elliptical path. Ellipse is a special curve where the sum of the distances from any point within the curve to two other points is always constant. The other 2 points are formed the foci of the ellipse. The more similar an ellipse to the shape of a circle. The circle shape is a special case of an ellipse where the two foci are located in the same position. Kepler's first law explains that all planets orbit the Sun in a path similar to an ellipse where the Sun serves as the center located at one of the foci of the ellipse.
John Christian R. Almanan, and I will present Kepler's law of equal areas. Second law. This law explains that the speed of planet as it moves around the Sun. A planet moves faster when it closer the Sun, and slower when it farther away. If an imaginary line connects a planet to the Sun, this line sweeps out equal areas in equal time interval. This means that although the planet's speed changed, the area covered over equal time period remain the same. When Earth is near the Sun, the swept area form a wide short triangle, and when it is far, it form a narrow long triangle but both areas are equal in size. This happens because planets adjust their speed to keep the area sweep constant.
Greetings, my name is Carvara Madrid, and I will present the law of harmonies. Kepler's third law is also known as the law of harmonies. This compares the orbital periods in radius of orbit of one planet to the other planets. The third law comparison between the motion trails of different planets that makes it different from the first two Kepler's law that only describe the motion characteristics of a single planet. This comparison is that the ratio of the square of the periods to the cube of their average distances to the Sun will be the same every single planet. For example, look at the orbital periods in the orbital radius of Earth and Mars indicated in the tables below. Okay, in tables 3.2 is orbital periods in the orbital radius of Earth and Mars. An Earth period is 3.156 times 10 raised to 7s. or the sample is 1 years. Then in Mars is 5.93 times 10 raised to 8s, or 1.88 years. And the average distance is for Earth is 1.4957 times 10 raised to 11 m. And then in Mars is 2.278 times 10 raised to 11 m. This means Mars is farther away from the sun than Earth. In that T2 raised to R3, this ratio shows the relationship between the square of the orbital period and the scope of the orbital radius. 2.9977 times 10 raised to 11 negative 19. Then in Mars is 2.977 times 10 raised to negative 19. Notice that the T2 and R3 ratio between the two planets is the same. This indicates the law of harmonies that all planets the same value for the T2 R3 ratio. Then I will explain the table stands 3.3, the orbital periods and orbital radius of the planets in the solar systems. We'll start in the Mercury. Mercury period is 0.241 or 80 days, and then the average distance is 0.339 or 39 AU, or analytical as astronomical units, or 58 million kilometers away. And then ratio is 0.98. The ratio between the square of the periods and the cube of the distance. And then the Venus is the period is 0.615 or 225 days. Then the average distance is 0.72 AU, around 108 million from the sun. And then the ratio is almost 1, shows that Venus follows Kepler's law very closely, so 1.01. And then the Earth is period is 1.000 years, or 365 days to orbit the sun. This is the standard for measuring all other orbitals by units. The average distance is 1.00 AU, or about 150 million kilometers from the sun. And then the ratio is 1.00, defined based on Earth orbit. The ratio equals 1 exactly. And then the Mars period is 1.88 years, or Mars takes about 687 Earth days to complete one orbit. And then the average distance is 1.52 AU. Mars is 1.5 times farther from the sun than Earth, about 228 million kilometers away. Then the ratio is 1.01, very closely to 1. And then the Jupiter is 11.8 years, the largest planet. Then the average distance is 5.20 astronomical units, or AU, around 780 million kilometers away. Then the ratio is 0.99, slightly below 1. Small variations are due to measurement and orbitals and eccentricity. Then, Kepler's third law of planetary motion gives an accurate description for the time and distance for each planet's movements around the sun. And then the key points is the first law of planetary motions, or law of epilepsy, states that the planet path around the sun is elliptical in nature, where the sun is located at one focus. And then the second law of planetary motions, or law of equal areas, states that there is an imaginary line from the center of the sun to the planet, and it sweeps out equal areas within equal time intervals. And the third law of planetary motions, or law of harmonies, states that the ratio of squares of the period between any two planets will always be equal to the ratio of the cubes of its distance from the sun. And that's all. Thank you.